What is gravity?
You have no idea. Okay, next question.
I don't know.
Nobody in the entire world knows why that falls.
So what is pushing this?
Here. Why does that fall?
Newton didn't know.
We can describe it pretty accurately, but no one knows why.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it.
I don't need a computer to get a kid interested in that. To spend a week playing with gravity and trying to understand it and come up with reasons why.
So what is pushing this?
I don't know.
Nobody knows why.
So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull.
Long before the theory of gravity was a glimmer in Newton's imagination, the natural physics of density and buoyancy already perfectly explained why apples fall down. Objects fall or rise based on their relative density to the medium surrounding them. Apples fall because they are denser than the air, while helium balloons rise because they are lighter.
No gravity necessary.
This is why raindrops fall down through the air and air bubbles rise up through water. Everything seeks its relative density and rises or falls until settling accordingly. This is why a tiny pebble sinks to the bottom of the ocean, but gigantic cruise ships and aircraft carriers stay afloat on the surface, because even though a pebble is so small, its mass, relative to its volume, its density, is more than water, so it sinks. And even though a cruise ship is so large, its mass, relative to its volume, is less than water, so it floats. If Newton's apple had landed in a puddle, he would have seen the apple only fell through the air because it was denser than the air, but then floated on top of the water because it was less dense than water. The natural physics of density and buoyancy was understood and agreed upon for centuries before they changed our textbooks.
What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
So did I accidentally ask a deeper question than I meant to?
Yeah, no, you were meant to ask deep questions.
Apparently I was.
In life. So to say, what is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time. And objects will follow the curvature of space-time, and we interpret that as a force of gravity. That's probably the best answer I can give to a what is gravity question, or why is there gravity. That's the best I can do there. I think that's a good start. And I can also say that Einstein noted that matter tells space how to curve, space tells matter how to move.
Say that again.
Isn't that beautiful?
It is. No, I want to get that. I
Yeah,
like
so,
that. That's a t-shirt.
matter and energy will curve the fabric of space.
Okay.
And it's that curvature that tells other matter how to move in the curvature of space itself. And so Einstein juxtaposed those in a poetic phrase where he said, matter tells space how to curve, did I get that right? Yeah. Matter tells space how to curve, space tells matter how to move. It's beautiful.
That is